Welcome. In the last video, we talked a little bit about the built-in functions in Python and how those apply to lists. However, we're going to change the topic slightly and start talking about 2D arrays or 2D matrices and array references. In this video, we are going to look at how to create a 2D matrix, how to do some manipulations on that 2D matrix, and the issues we have when referencing an array inside of another array. We have already seen how to work with one-dimensional arrays, but how about two-dimensional arrays, such as the one on line 9 over here? Now, it is a two-dimensional array because it's an array since it contains square brackets on the outside, but it's two-dimensional because it contains other arrays. So it's an array of arrays. And so we ask ourselves, how do we query an element from such a structure? And the way we can do this is to first query the row that contains our element. So suppose we want to query 11, then we grab this row, and then within this row we get that element. So it would look something similar to nums2d, get the index of the second row, which is 1, and get the index of the element we want. So I want to grab 11, and that is at index 3, and it's that easy. And for each dimension, all we need to do is add another square box, and we can grab the element within that extra layer, if you will. Now, the reason I have these import statements up here, this one we're going to use later, but this line over here imports a function called prettyprint from the prettyprint module. We're going to talk about modules in a later section, so right now all I need you guys to understand is that prettyprint is a function from elsewhere and we are importing it into our project. So if we did the traditional print on nums2d and print it out, it's hard to read because everything is on one line. However, if we use the prettyprint function with nums2d, we get a much more readable representation of the matrix. So now we want to change the element 17 to be, say, -5. So to do this, we get the third row, which is at index 2, and then we get the second element, which is at index 1, and then we can assign it a value. I want that to be -5. And then we can print our matrix again. And then here we have the old matrix and the new one, except that this time there is a -5 right there, just as we wanted. So now that we understand how to query and assign values to a 2D matrix, let's take it a step further. Let's create a one-dimensional array called letters. I want to create a two-dimensional matrix of letters. So I can say letters 2D is letters, letters, letters. Just like so. Oh, make sure you put a comma there. This is two-dimensional because it's an array and letters itself is an array. Now let's prettyprint this and see what letters 2D looks like. And letters 2D is just a 2D array containing array letters 3 times, as we would expect. However, observe what happens when I assign a value to letters 2D. Suppose we assign A, the very first A, which is the A in this array letters. So that would be row 0, index 0, and instead of A, let's put an F. And let's print our matrix again. When I run this, something interesting happens. Not only did it change the first A, but it changed all the other ones. Why did that happen? Why are these two not A's as we would expect? The reason is, since these are identical, they are not copies of letters. They are a reference to letters. So once we change something inside the 2D matrix, which points to letters, it changes letters itself, which can cause bugs like this, which we do not necessarily intend for. So the way to get around this is to copy letters into this array 3 times. This is why I imported these copy functions, so copy and deep copy. Copy simply copies the elements that we want. However, deep copy is for compound variables or expressions. And what I mean by a compound object is like a list containing a list, or an object with multiple fields. Since we're only dealing with a one-dimensional thing, all we need to use is copy. But if you're working with something more complicated, make sure you use deep copy, which uses recursion to copy elements in. So to fix our bug, let's create a unique copy of letters for each of these arrays. If we rerun this, since each row in the letters 2D matrix is unique, changing the first one will only affect the first row. So it's important to understand that we need to make a copy of this array so that we don't shoot ourselves in the foot when we assign a value like this. In this video, we covered how to create and query a 2D matrix and the issues with array referencing. In the next video, we're going to look at the special topic of list slicing. See you then.